Hi, all students of ninth class. Welcome back to our maths class, Maths with S. Ramunaidu. This is yours S. Ramunaidu, School Assistant Mathematics at JPHS, Atvelli, Medchal Malkasgiri district. Now, let me go to ninth class mathematics. I think this is our first mathematics class from me. In this particular chapter, we can discuss about, we can know about chapter 6, linear equations in two variables. Linear equations in two variables. These students already we have known what is a linear equation. Just recall, linear equation, the equation which represents a line. The equation which represents a line is known as a linear equation. In our 7th and 8th class, we have learned linear equation in one variable. That means a equation, an algebraic equation with degree 1 is a linear equation. In those linear equation, if it has one variable, that is linear equation in one variable, it has a unique solution. A linear equation has a unique solution. Why? Students, just recall, it has only one variable. So it has one value, one solution. Value of one variable. Now, let us move into linear equation in two variables. Just in this session, just we can discuss about introduction. In class 9, what is introduction? Just what is the definition of linear equation in two variables? Remember or recall linear equation in one variables. We can discuss general form of linear equation in two variables and condition for linear equation in two variables and compare a given linear equation which is given in one variable as can represent as linear equation in two variables and finding or compare quantities, I mean constants. And the most important thing is express as a linear equation of a given statements. Dear students, let us move. Linear equation. Already just we discussed here linear equation. An equation with degree 1, an algebraic equation with degree 1 is known as linear equation. In this linear equation, now we have already known linear equation in one variable, a linear equation with one variable which has One variable is known as linear equation in one variable. What is the other one? Linear equation in two variables. Linear equation in two variables. This means it is a linear equation. It has two variables. A linear equation with two variables is known as linear equation in two variables. Before going to discuss our definition, just see examples for linear equation in one variables. Equations like x plus 3 is equals to 0, y minus 13 equal to 0, 2x plus 5 is equal to 0. Dear students, observe here x, y, x. These are variables. In this particular equation, we have only one variable. In this equation, we have only one variable. In this equation, we have only one variable. So these are all examples for linear equations in one variable. These are all examples for linear equations in one variable. Now, let us move into linear equations in two variables. Students, observe here. Equations like x plus 2y is equals to 5. 2p minus q is equals to 4. 3m plus 4n equal to 14. Students, observe here. What are variables? Here, x is one variable and y is another variable. P is one variable, q is one variable, m is one variable, n is one variable. Here, this is an equation with two variables. This is an equation with two variables. This is an equation with two variables. The degree of these equations is 1. So the degree is 1. These are known as linear equations in one variables. Sorry, the degree is 1. These are linear equations. But these have two variables. So these are examples for linear equations in two variables. These are examples for linear equations in two variables. Dear students, I hope you are all understand the definition types of linear equations. Linear equation in one variable and the other one is linear equation in two variables. Now let us move to definition of a linear equation in two variables. Now we can discuss about definition. Just students, you can guess what is the definition. If a linear equation in two variables, if a linear equation has two variables, then it is known as, if a linear equation has two variables, then it is called a linear equation in two variables. It must be a linear equation, that means with degree 1 and with two variables, then it is known as linear equation in two variables. It is usually denoted by variables x and y. As usually we can use x and y, but other letters may also be used. What are other letters? We have 26 alphabets in English alphabets. So A to Z, A3, ABC, whatever it may be. And several times we can use x and y. Observe here, dear students, 4x plus 2y is equals to 100 is an example of linear equation in two variables. Observe here, the degree of the order is exponent is 1, here exponent is 1, so degree is 1, the degree of linear equation is 1, this is a linear equation. it has two variables. It has two variables, x and y. So it is an example for linear equation in two variables. It is an example for linear equation in two variables. Observe here, students, p plus 3q equal to 50. P plus 3q equal to 50. 3u plus 2v is equal to 11. Observe here p and q. P and q. Two variables. The degree is 1. So this is a linear equation in two variables. 3u plus 2v is equals to 11. 3u plus 2v is equals to 11. Observe here, u and v are two variables. The exponents are 1. This is a linear equation in two variables. This is a linear equation in two variables. And 5s minus 2t equal to 3, where s and t are variables and the degree is 1. So this is a linear equation in two variables. 5x minus 7y is equals to 3. 5x minus 7y is equals to 3. Observe here, x and y are variables. Degree is 1. So this is also an example for linear equation in two variables. Dear students, these are all examples for linear equations in two variables. You may also guess some more examples for linear equation in two variables. Now, just how can just imagine how can we write it is we can put the above equation in the form. Observe here, this is plus 50. If we can move to LHS, this can be written as p plus 3q minus 50 equal to 0. This we transpose plus 50 to LHS, we can get minus 50. If we transpose plus 11 to LHS, this is minus 11. If we transpose plus 3 to LHS, minus 3. If we transpose plus 3 to LHS, minus 3. Just 3u. This is, I forget to write, 3u plus 2v minus 11 is equals to 0. Okay, students, these are all. And we can write p plus 3q is equal to 50 as p plus 3q minus 50 is equals to 0. So observe, from using these forms, we can write the general form of a linear equation in two variables. Now let us discuss about general form of linear equation in two variables. General form of a linear equation in two variables. Already just we said ax plus by plus c is equal to 0. But there is some condition for represent a linear equation. What is the general form of a linear equation? Just observe. According to our previous examples, the general form of a linear equation, the general form of a linear equation in two variables xy is ax plus by plus c is equals to 0. Dear students, so observe here, where x and y only are variables, we treat x and y as variables and a, b, c are real numbers. Where a, b, c are real numbers. Where a, b, c are real numbers, x and y are variables, then the general form of a linear equation is ax plus by plus c is equals to 0. Ax plus by plus c is equal to 0. What is the condition for this? Ax plus by plus c is equal to 0 represents a linear equation. Both a and b are not simultaneously 0. That means both are not 0 at same time. Both are non-zeros at same time. Otherwise, we have another definition. Yes, in general, an equation of the form an equation of the form ax plus by plus c is equals to 0. An equation of the form ax plus by plus c is equal to 0, where a, b, c are real numbers, a, b, c are real numbers, and where at least one of a or b is not 0. Already we discussed here, a, b are not simultaneously 0. That means if a is 0 but b must not be 0. If b is 0, a must not be 0. Then this is written as a square plus b square not equals to 0. This is the condition for. This is the condition for. Dear students, this is very, very important. The condition for. The condition for ax plus by plus c is equal to 0 represents a straight line or a linear equation is a square plus b square not equal to 0. A square plus b square not equal to 0. This is called a linear equation in two variables x and y. An equation in the form a plus b plus c is equal to 0, where a, b, c are real numbers and where at least one of a or b is not 0. That is, a square plus b square not equal to 0 is called a linear equation in two variables x and y. I think these students have you have understand this. Otherwise, just you can repeat this. Students, just uh, we discussed about the general form of linear equation in two variables. Now we have to know, compare a linear equation in one variable with linear equation in two variables and find the values of constants. That means, observe here, students, dear students, observe here, express each of the following equations in the form of ax plus by plus c is equal to 0 and write the values of a, b and c. Express each of the following equations in the form of ax plus by plus c is equal to 0 and write the values of a, b and c, where just if I get to know you, where a, b, c, where a, b, c are real numbers and constants. These are called as coefficients, constants, real numbers. A, b, c are real numbers and a square plus b square not equal to 0. That is most important. If a square plus b square not equal to 0, this ax plus by plus c is equal to 0 represents a linear equation in first 3x plus 4y is equal to 5. We can find the value of a, b, c. For that, first we express the given equation 3x plus 4y is equal to 5 in the form of ax plus by plus c is equal to 0. Students, understand? We can express 3x plus 4y is equal to 5 as ax plus by plus c is equal to 0. The general form of a linear equation in two variables is ax plus by plus c is equal to 0. Yes, you can guess. Your guess is right. The general form of a linear equation in two variables is ax plus by plus c is equal to 0. First, we can write 3x plus 4y is equal to 5 can be written as this is equals to 5. This is equal to 5 is transposed to LHS. This can be written as minus 5. This is plus 5. We can move into LHS. This is minus 5 is equal to 0. Students, by compare with ax plus by plus c is equal to 0, all of you compare the given equation with ax plus by plus c is equal to 0. A is equals to 3. Since observe here 3x plus 4y, this minus 5 can be written as plus of minus 5 is equals to 0. Students, observe here. A is equals to 3. Yes. B is equals to 4. Then C is equals to minus 5. So 3x plus 4y is equal to 5 can be written as 3x plus 4y minus 5 is equal to 0, where A is equal to 3, B is equal to 4, and C is equal to minus 5. Now let us move to x minus 5y is equal to 3y. X minus 5 is equal to 3y. This can be written as, observe here, x means 1x plus 3y transpose to LHS minus 3y. Minus 5 is equals to 0. By comparing with ax plus by plus c is equal to 0, where a is equals to, where a is equals to, a is equals to 1, b equal to minus 3, c equal to minus 5. Observe here. Okay, I hope you are understand. Then move to third one. The equation 3x is equal to 5. Sorry, 3x is equal to y. The equation 3x is equal to y can be written as 3x, this plus y, this plus y, transport to LHS minus y. There is no constant, so we can use plus 0. This is the important. And oftenly, sometimes we can make mistakes like this only. Easy mistakes. 3x minus 1. There is no constant, so you put plus 0 instead of constant is equals to 0. These students, by compare with ax plus by plus c is equal to 0. By compare with ax plus by plus c is equal to 0. Observe, a is equals to 3. B is equals to, there is no value, this is 1. C is equals to 0. So A is equal to 3, B is equal to minus 1, and C is equals to 0. I hope we have another example. 3x minus 7 is equals to 0. Dear students, 3x minus 7y is equals to 3x minus 7 is equals to 0. In this, we have x, y, I mean x constant, y constant, constant. In this, we have also x constant, y constant, constant. But here, there is no constant. Here, there is no y coefficient. Understand? There is no y terms. So 3x minus 7 is equal to 0. 3x. Here, there is no y term. So we can write this is as 0 into y. 0 into y, that is 0y. Minus 7 equal to 0. By compare with ax plus by plus c is equal to 0, these students, all of you know, a is equals to 3, b is equals to 0, c is equals to minus 7. A is equal to 3, b is equal to 0, c is equal to minus 7. I hope you all understand the general form of students. Already we have discussed the general form of linear equation. The general form of linear equation in two variables, that is ax plus by plus c is equal to 0. In previous example, we have learned to compare a linear equation in two variables and also a linear equation in two variables with general form and find the value of a, b, and c. Now we can see another example. Write each of the following equations in the form of ax plus by plus c is equal to 0 and find the values of a, b, and c. The first one is nothing but x is equal to minus 5, y is equal to 2, 2x is equals to 3, 5y is equals to minus 3. For comparing, first we have to write the general form of, yes, you can recall the, yes, you memorize it. The general form of linear equation in two variables is ax plus by plus c is equal to 0. The general form of a linear equation is in two variables is ax plus by plus c is equal to 0. Students, first x is equals to minus 5. X is equals to minus 5 can be written as, for example, this is x, this minus 5 transposed into LHS is plus 5 is equals to 0. The students, observe here, there is no y term, so we can write this is as 1x. There is no y term, so this can be write as 0y plus 5 is equals to 0. Students, observe here, observe here, a is equals to 1, b is equals to 0, c is equals to 5. A is equal to 1, b is equal to 0, c is equal to 5. So x is equal to minus 5 can be written as 1x plus 0y, 1x plus 0y. Therefore, a is equals to 1, b is equals to 0, and c is equals to minus 5. We can move to second example. Y is equals to 2. Then we can write y minus 2 equal to 0. Y minus 2 is equals to 0. Students, there is no x term, so we can write this is a 0x. There is no coefficient, that is 1. 0x plus 1y minus 2 equal to 0. By compare with ax plus by plus c is equal to 0, a is equal to 0, b is equal to 1, and c equals to minus 2. A is equal to 0, b is equal to 1, c is equal to minus 2. We can move to third example. 2x minus 3, 2x minus 3. Students, 2x minus 3, 2x. This is equals to 3. Transport to LHS, this can be written as 2x minus 3 is equal to 0. There is no y term, so you can write this is a 0y, 0. By compare with ax plus by plus c, by compare with ax plus by plus c, a is equal to 2 and b is equal to 0 and c is equals to minus 3. A is equal to, b is equal to 0, c is equals to minus 3. Okay, students, now let us move to another example. Let us move to another example, that is, what is the another example? 5y minus 3. Just write, yes, you can try. 5y minus 3 equal to 0. Now, this is 5y minus 3 transport to LHS. It can be changed as plus 3. 5y plus 3 is equal to 0. There is no x term, so we can write this is at 0x. By compare with ax plus by, a is equal to 0, b equal to 5, c equal to 3. Okay, a is equal to 0, b is equal to 5, c is equal to 3. I hope you are all able to do any problem like this. This means we have some more problems in exercise 6.1 in our 9th class textbook. Into another concept. Expression as linear equation in two variables. How can we express? Already we know expression of a linear equation. If we have a situation, can we express as a linear of a linear equation, a system of linear equation? Suppose here Hama's age is 4 times the age of Mary. Hama and Mary are some two friends. Hama's age is our daughter and mother, whatever it may be. Hama's age is 4 times the age of Mary. Write a linear equation in two variables to represent this information. Hama says, dear students, first of all, we understand the question. If we understand the question very well, we have get the answer easily. Otherwise, we can't write answer. Hama says is 4 times the age of Mary. Write a linear equation in two variables to represent this information. Dear students, first identify what are variables. Hama's age, Mary's age, Mary's age and Hama's age. These are variables. And that means what are unknown quantities? Ages of Hama and Mary. The age of Hama and that of Mary are unknown quantities. Now we can take already just uh, we have no we knew we take A B C X Y Z as for unknown quantities. Now let Hama says be X years and of Mary be Y years and that of Mary be Y years. Just we take the age of Hama is X years and and the age of Mary be Y years. If Mary age is Y, then Hama age is 4Y. Why? Because 4 times of Mary. 4 times of Mary. So, if Mary's age is Y-S, for example, Mary's age is 10, Hama's age is 4 times of Mary, 40. If Hama's age is, Mary's age is 5, Hama's age is 4 5s are 20. So, if Mary's age is Y, then Hama's age is 4Y. According to the given information, Hama says is 4 times the age of Mary, x is equal to 4y. If we transport plus 4y moves into LHS, x minus 4y is equal to 0. This is a linear equation in two variables. This is a linear equation in two variables. Dear students, understand this. This is a linear equation in two variables. Okay, students, I hope you all understand this. Let us move. Just students, already we have an example. We learned how to express a linear equation in two variables. How can we express a situation as linear equation in two variables? Already we have seen an example. Now we've seen another example. One day, Kavya went to a bookshop with her father to buy 4 notebooks and 2 pens. One day, Kavya went to a bookshop with her father to buy 4 notebooks and 2 pens. Her father paid 100 rupees for all these. Kavya did not know the cost of the notebook and the pen separately. Now can we express this information in the form of an equation? Observe here, students, what are variables? The most important thing is identify the variables. What are the variables? The cost of he paid rupees 100 rupees. The cost is rupees. What what are variables? What are unknown quantities? Yes, the cost of a pen, the cost of a book. The cost of a pen, the cost of a book are the cost of a pen and cost of one notebook are unknown quantities. Here you can see, students, here you can see the cost of the single notebook and also of the pen is unknown. That means the cost of one notebook and also one pen. The cost of one pen is unknown. The cost of one notebook and that of the pen is unknown variables. There are two unknown quantities. Now let us take that unknown quantities as x and y. We use x and y to denote these unknown quantities. What are unknown quantities? Cost of single notebook and also that of pen. Let the cost of a notebook be x rupees and the cost of a pen be y rupees. The cost of a notebook be x rupees and the cost of one pen be y rupees. Now observe here the cost of four notebooks. Yes, Kavya bought four notebooks. Kavya bought four notebooks. The cost of one notebook is x rupees. The cost of four notebooks be 4x. Since if the cost of one notebook be 10 rupees, if the cost of one notebook is 10 rupees, then the cost of four notebooks is 4 into 10 is 40 rupees. Yes, you are. Then the cost of two pens be, the cost of one pen be y rupees, then the cost of two pens be 2y rupees. How much her father paid? 100 rupees. So the total cost of four notebooks and two pens is 100 rupees. The total cost means the sum of 4x plus 2y. Yes, the sum of 4x plus 2y is nothing but 100. This is the linear equation in two variables. This is the linear equation in two variables. To another example. One day, let us move into another example. All of you read this question. One day, Siri went to a bookshop with her father and bought three notebooks and two pens. One day, Siri went to a bookshop with her father and bought three notebooks and two pens. Her father paid 80 rupees for them. 80 rupees for three notebooks and two pens. Her friend Lakshmi. Her friend Lakshmi liked the notebooks and pens. Suppose Siri take this school. Her friend Lakshmi liked these notebooks and pens. So she too bought four notebooks and three pens of the same kind for 110 rupees. Express above situation as pair of linear equation in two variables. Students, once again we repeat. One day Siri went to a bookshop with her father and bought three notebooks and two pens. Her father paid 80 rupees for them. Her friend Lakshmi liked the notebooks and pens. So she too bought four notebooks and three pens of the same kind for 110 rupees. Express the above situation as pair of linear equation in two variables. Observe what are unknown quantities here. With cost of one book and cost of one pen are variables are unknown quantities. Cost of one book and cost of one pen are unknown quantities are unknown values. These are taken as variables. Now for variables we can take x and y. So we have two situations which can be represented as follows. Just let cost of one notebook be x rupees, cost of one notebook be x rupees, and the cost of one pen be y rupees. Understand, students? Let cost of one notebook, this is unknown quantity, cost of one book and the cost of one pen be y rupees. First, we try to write linear equations for series amount. I mean series spended amount. Siri paid 80 rupees for 3 notebooks and 2 pens. That means her father or C paid 80 rupees for 3 notebooks and 2 pens. That means the cost of 3 notebooks and 2 pens together 80 rupees. Total cost of 3 notebooks and 2 pens be 80 rupees. The cost of one pen, one notebook X. The cost of 3 notebooks, is 3x. The cost of one pen be y rupees. The cost of 2 pens be 2y. Total cost means 3x plus 2y. Observe here, 3x plus 2y is equals to 3x plus 2y is equals to 80 rupees. What is the total? 80. Understand? The cost of one notebook x, cost of 3 notebooks 3x, cost of one pen y, the cost of 2 pens 2y. The total cost 80. So 3x plus 2y is equals to 80. Now Lakshmi also bought the same types of notebooks and pens as Siri. Observe here, the notebooks and pens are same as Lakshmi and Siri both are bought. So the cost of that notebook, one notebook be x rupees, the cost of one pen be y rupees. Also, Lakshmi paid 110 rupees. Lakshmi paid 110 rupees for 4 notebooks and 3 pens. Now, observe here, total cost of 4 notebooks and 3 pens be 110 rupees. Now, the cost of one notebook X, 4 notebooks be 4x rupees. The cost of one pen be y rupees. The cost of 3 pens be 3y rupees. So total cost 4x plus 3y. Total cost 4x plus 3y. But what is the total cost spent? Means 110 rupees. 4x plus 3y is equal to 110 rupees. These two are linear equations in two variables for the given. Now, what is the solution of linear equation in two variables? Solution of linear equation in two variables. For example, if we have a linear equation x plus y is equals to 5. Just I write here a simple equation. For example, you take the value of x as 1, value of y as 1. 1 plus 1 is equals to, what is the value of 1 plus 1? This is 2. But here x plus y is equal to 5. But if we take x as 1, y as 1, the sum is 2. Is they are equal? No, they are not. Are they equal? No, they are not equal. So this is not solution. Some of you take, if the value of x is 1 and the value of y is 4, what is the sum of 1 and 4? Is nothing but 5. Is it satisfied? Yes. The value of x is 1 and if the value of y is 4, it satisfies the equation. Then it is the solution for x plus y is equal to 5. Then if you take x is equal to y is equal to 3, x is equal to 3, y is equal to 2, x is equal to 0, y is equal to 5, x is equal to 5, y is equal to 0, x is equal to 4, y is equal to 1. This is 1.5, this is 3.5. This is 0.5, this is 4.5. How many? How many solutions for a linear equation? Clearly we know x plus y is equal to 5 represents a straight line. So a straight line have infinitely many points on it. So each point of a straight line is solution of that equation. So a linear equation has infinitely many solutions. A linear equation has infinitely many solutions. Now let us see some more examples here. Therefore, any pair of values of x and y which satisfies the linear equation in two variables is called its solution. Therefore, any pair of therefore any pair of linear equations, any pair of values x and y which satisfies the linear equation two variables is called its solution. Just we discussed. Any values of x and y which satisfies the linear equation two variables is called its solution. For our previous example, 4, 1, 2, 3, 3, 2, 1, 4, 1.5, 3.5, these are all solutions for that particular linear equation. Just observe here, 3x minus 2y is equal to 5. Just I'm trying to write a solution for this. If x is equal to 3 and y is equal to 2, if we substitute x by 3, 3 3 is 9, minus y by 2, 2 2 is 4, 9 minus 2 is equal to, sorry, 9 minus 4, 2 2 is 4, 9 minus 4 is equal to 5. So here both LHS and RHS are equal, so the x is equal to 3 and y is equal to 2 is solution of 3x minus 2y is equal to 5. This solution is written as an ordered pair 3 comma 2. Here this solution is written as 3 comma 2. This solution is written as 3 comma 2. How many solutions for this linear equation? Just we discussed now, this linear equation has infinitely many solutions. For example, suppose we take x is equal to 4. How can we solve? Just I recall our 9th class concept. If let x is equal to 4, what is the value of y? What is the solution? For 3x minus 2y is equal to 5. If we substitute x is equal to 4, 3 4s are 12. 12 minus 2y is equal to 5. 12 minus 2y is equals to 5. Now we have, which is an equation in one variable. We have an equation in one variable. For solving the meaning of solve this, we can find the value of y. Observe here, on solving, we get 12 minus 2y is equal to 5. For example, this is plus 2. We transpose it into RHS 5 minus 12. What is the value of 5 minus 12? Is equal to minus 7. Minus 2 is multiply here. If we transpose it, it divides. Otherwise, if we multiply this number both sides by minus 2, if we divide by minus 2, y is equal to minus 7 by minus 2. Minus by minus into minus, plus the value of y is equal to 7 by 2. Now what is the solution? For here 4 and 7 by 2. Here 4 comma 7 by 2, where the value of x is 4 and 7 by 2 is value of y. This is called as ordered pair. We can write the solutions in the form of ordered pair. Here this is x coordinate, this is y coordinate. Suppose, just dear students, you can write, do you find some more solutions for 3x minus 2 is equal to 5? After watching this video, you can try to find some more solutions on the basis of if you take any values of x and y, we can convert the equation into one variable, then we can find the
value of other variable, we can get the final solution.
Students, I hope you are all understand the introduction of linear equations in one variable or two variable 6.1. We can meet again with solution of linear equation in two variables and a graphical representation of linear equations in two variables and some more examples to express the given situation as linear equation in two variables. Thank you for watching this video. This is your boss S. Ramunayudu, School Assistant Mathematics. See you again. Thank you.